Well, that it's the one half of the determinant, which is like it's like B is a triangle like that. Like B's components is like B1 is that direction, and like would be like the X part of the graph, and then B2 is the Y part, like the up and down or left to right. Like the left and right is one B the B component one, and up and down is B component two. But then it's like that for both for A and B. And then I found out for the to find what a quanta is, you make it, you do the calculus for the one half determinant. The determinant is like that one part of A times the second part of B minus the second A part of A component of A times the first part of B, and then going in the opposite. And then if you're to instead of like a and then that is equivalent to it's the first part of A is like the differential equations. The first part is like the first part for the quotient rule in calculus, like for like if it's like what is if it's like x plus 1 divided by x plus 2 is equal to the function of x, then how do you find like the prime function of x, which is the derivative, the calculus thing, like one of the calculus operations to the equation? It's it's the like to find the f prime of x, of where x plus 1 would be g of x, and x plus divided by x plus 2 would be h of x. So it's g of x divided by h of x, and then it becomes g prime times h. It's the g prime of x times h of x minus g times h prime of x. So it's like the first g part, the first g part, and then times g1 is like a2 or whatnot, which is like the determinant. It's or whatnot, like it's like the negative. It might be like the negative part of like the negative area. Oh, but then but basically, if you make the b part, instead of it being just being two different vectors, if you make the b part be a unit vector, which is like over there on the thing, like it's defining components of it is like the unit vector. And then so the unit vector of b, if you just made it be the unit vector to find like a unit for like a linear like function, like a line, whatever it is, like there's a magnitude, like a vector, like a vector, like just like an energy or something like that. Then you divide it by like its unit vector, which is like a unit vector, which would be like it's like a unit. It's like the standard of unit, and then so it gives like a quotient rule. So then it's basically like the like it becomes like the area divided by the unit vector, which is like the b component, the unit divided by the, or like the area of the volume, like the displaced area is like, which is like the displaced area is like an energy. So like and then so it's like basically like a particle times the unit vector is equal to the unit vector divided by, I'm not the unit vector, is equal to the area divided by the unit vector. So like the area divided by the unit vector is equal to the particle times the unit vector, and then like so like one is like times the unit vector, one is divided by the unit vector. So it's like the particle is equal to like the area, and then and then it's like that would go with like equals mc squared, or like c squared. So it's like, well, what's c? Well, a c squared is a squared is an area. So that like goes with that, and I'm pretty sure that like the determinants and stuff is like how you get tensors and Ricci tensors and stuff, like with matrices and stuff like that, which is what Einstein used for for to prove general relativity, and like how deflected stars would be in the sky from during an eclipse in like 1908 or 1918, whenever it was it happened. I'm pretty sure that's about it. Just like that unit vector is like it's like the iota. I'm pretty sure that's all it is. But then it's just, yeah, I'm pretty sure that's all.